Alright, hey and welcome to example 8 in the Pyro tutorials. And this one we're going to take a look at explosions and how to set them up. So to begin with, we want to create a really cool source for explosion. We're going to go over that in here in subs, and then we're going to dive into DOPs. First of all, I'm just going to show what the explosion is going to look like that we're going to create. It's quite basic, but I think it looks cool for our beginning. So let's see. So I'm simming here. And it's basically just this. Kind of smallish, kind of not so ecstatic or like exaggerated, but yeah. So from top, it's gonna look like this. Boom. Let's go over how to do this and see how we set it up. So first of all, we're gonna go over to the source. So the source is very important in explosions. Like, most of the part of how your explosion is going to look is in the source, and if it's actually set up well. So I'm going to go over how I usually do it. I do add a little bit more finesse to it, but this is a good way to start. So let's start with a sphere like this. We do primitive type to polygon. We add a little bit more frequency to get some more points in there. Then we add some noise with the mountains up. Usually that's a pretty good noise, so this should get us a good start. We want to look for these like directionalities in it, which are gonna look cool, like here, this and this. I think that's gonna look really good. And then we want to move the points that are below 0 in y-axis to origin or to the ground plane with this VOP. I'm just doing that by comparing and some stuff. You can go in here and check, but yeah. Anyway, I'm moving these points to the grid to just get the shape above 0, because that's what we're interested in. Next up, we're gonna animate this thing. So basically, an explosion is really fast. It's expansion of a volume that is like really hot, really fast, and really like a lot of energy to it. Therefore, we kind of want to start animating our source, even the geometry. So the geometry is now here set to scale of 0. We want to scale it up really fast and then scale it back slightly. So we're going to scale it up from 0 at frame 10, then go to frame 12 and scale it up to 1.3, and then go to 2 frames later and scale it back to 0.85. This will give us something that looks like this. It's really fast, boom. But it will give us a good expansion and a good like energetic first impact of the explosion, which is really important as well. A lot of explosion you will see that is CG lacks this energy in the initial like sourcing of it, which can give it away that it's fake and it's CG. So that's a good practice too. Next up, we're going to calculate the velocity of the points in this with a trail. We're going to put the result type to compute velocity. And that's all for our geometry, actually. We're done with the geometry. This should work fine as it is. Now we're going to create the source, the volumes or the fields for the Pyro. And how we're going to do that is with a source, fluid source, our regular node. So we're going to take a look at some fuel, temperature, and velocity. So let's start with the fuel and temperature. So the source attribute, we're going to put it to fuel, since we're not going to deal with density right now. Density can be added later on, but as a cause of the fuel and temperature. So only fuel and temperature is in the fields from this fluid source. So we're going to put 2 fields, one called fuel, one called temperature, and we're going to put the fuel to 0.4. I'm going to tell you later why I do that. I cannot scale it down because it gives too much fuel later on. But let's keep it at this for now. So next up, we want to, nothing here. We want to add some noise into this. I'm just quickly going to go over here and disable that. As we can see, we have quite a lot of breakup in our volumes here. And that's because of this noise. If I take this off, the use noise, it's going to look kind of like this. And it's kind of boring, it's kind of smooth and not interesting shapes. And that's why we want to use the noise. So we're going to take use noise, we're going to put the cell influence to 0.5, turbulence influence to 1, Pulse duration, we can lower it a little bit to get some faster action, but I think one is going to work quite well here. It's kind of oscillation of the noise. The element size, we're going to play with a little bit. I put it to 0.7, but depending on the scale of your scene, you kind of want to play with it. You don't want it to have too small elements. You don't have too like high frequent noise, because that's going to be uninteresting later on. You also don't want to have too big, because that's not going to make any change. So you want to find that sweet spot for your scale of your explosion. I found that 0.7 worked quite well for this. I seem to have some really cool breakup here and here, so I think that's going to work fine. And that's all for the fields, the volume fields for now. Next up, we're going to take a look at the velocity. So the velocity is going to look like this, and that's because we're sourcing the V attribute that this gives us, the calculate velocity node or the trail. The V is the source attribute, and it's going to create a vel field. We also want to turn on add curl noise. I haven't done anything to curl noise here, so I just clicked basically add curl noise, just to break up the noise a little bit more, to add a little bit more interest into it, since it's quite straight and boring like this. So let's just do that. You can lower the scale of it if you want, if you find that it's too much, or the swirl size. It's fine too, but I'm gonna keep it at this. And that's all we need for now. Actually, we now have all the fields. We have temperature, fuel, and velocity. As you can see, if we middle mouse click this, we have fuel, temperature, vel x, vel y, and vel z. Great, that's all we need for a source. So now we're gonna put a null here that's called add fuel, and we're now gonna dive into the DOP to take a look at how we set up the actual simulation. All right, cool. So in here we have a couple of things. We have a couple of nodes here that I want to go over, but first of all, we're gonna take a look at the sourcing of these fields. As always, we're gonna use the source volume. We're gonna find the path to our null object. I'm gonna go over this a little bit. We're gonna put the scale velocity to 0.3. That's also up your preference and how it looks. It's obviously a multiplier of the velocity field or the vel field, so you're gonna have to kind of dial it in depending on what you want to create. But I found for this simulation, 0.3 works quite well. In the volume operations, we're gonna put the velocity to add instead of copy, which will basically just add the velocity field on top of any other velocities in here, such as turbulence or anything like that. In particle operations, nothing, masks, nothing. Sub to DOP, we want to put the source volume to fuel. Since we don't have density, we want to source it through the fuel field. And we're going to add that to the field called fuel. So fuel and fuel in these two. And that's it for the sub tabs here. Next up, we want to talk about animating the scale source volume. All right, so as we remember, we animated the scale of the original geo. We also want to animate when and how much volume is sourced at what frames. Since explosion is quite fast, it happens instantaneously almost, and most of the fuel is going to be consumed. We don't really want any fuel to be lingering and like sourcing throughout the whole simulation. So we want to quickly turn it on and then quickly cut it off quite fast afterwards, just a couple of frames later, to just get the illusion of a fast sourcing and everything is consumed, basically. So we're gonna animate this scale source volume, and this is this is a multiplier for the volume we are sourcing, which is the fuel. So if you go down here to this brain down here, we're gonna click it. That turns off any simulation. So Houdini won't simulate anything now. And we're just gonna put some keyframes down. So remember, the scale of it is 0 at frame 10. Therefore, we wanna put the scale source volume to 0 at frame 10 as well. We're gonna right click it, go to channel and keyframes, and we wanna put set keyframe. Then 2 frames later on frame 12, we remember that the scale of the source geometry was 1.3. It had expanded from 0 to 1.3 over 2 frames. Therefore, we want to actually also scale our source volume quite a lot over only 2 frames. So on this frame, we're gonna put the scale source volume to 10. So right click, channel keyframes, and set keyframe. So now we have from 0 to 10 over 2 frames. Then we wanna start minimize, or actually lessening this. So 2 frames later, on frame 14, we're gonna put it to a really low value, because as you can imagine, all the fuel is almost burned up now. Almost all fuel is consumed. So here we're gonna put it to 0.22, which is a really low value, but a tiny fraction is still sourced. And then like 4 frames later, we're gonna put it back to 0. We don't want to source anything after frame 18, basically. So that's it for animating it. This is very good practice to animate all those things, kind of to get the actual animation control over it. Yeah, so that's it for our source volume node. Now we have the regular stuff. We have the Pyro node, which is the vision size and like the visualization of stuff. I put the visualization to multi-field to visualize both density and the emission that is going to be caused by temperature and heat. The emission scale is put to 5 just to get some more things in there, and the density scale is put to 4 as well. The resize container, I've just switched off the clamp to maximum. You can pad it a little bit more if you want to. You obviously have to put the reference field to fuel, or you could put the density still, because we are going to have some density, but regardless, not much changed in the resize container. We also have another kind of interesting node here. There's a gas microsolver called gas damp. So what this gas damp is gonna do is that it's kind of like a drag force for our field. It will cut off the velocity for a certain field that we're gonna find. So if we want to cut off velocity for a certain field, we can type it here, as I've done, called density, and then we can put the scale to some kind of value. So a scale of 0.06 will basically lower the velocity for each frame by 6%. Okay, it will reduce the velocity by 6% for each frame that this gas node is here, which is all frames, obviously. So it's kind of like a cool thing to, if you have too much velocity in a certain field, and you kind of want to make it a little bit less erratic or less blowing outwards, kind of. I like to use this one. Anyway, we're gonna take a look at what it does later on, kind of what difference it does switching it on and off. But that's all for nodes outside. We can add a merge down here with a ground plane. It's gonna look like this. But that's it for all the other nodes. Now let's take a look at the Pyro solver. So I'm gonna switch on the simulation again by clicking this. So the brain is back. Now we're live. Now we're simulating again. So in the simulation tab, we're gonna put the cooling rate to 0.8. In the combustion, which is the most important thing here for an explosion, we're gonna put the burn rate to a really fast rate, right? So for each frame, 98% of the fuel is gonna be consumed. All right, that's a really high rate, but it's also probably a physically correct rate because fuel is gonna be consumed really, really fast. The gas release, we're gonna put 19 instead of 15, which 15 is the default, but 19 is a little bit higher number, which means that more gas will be released, the expanding of our fuel and volumes will be a little bit broader, which is gonna look really cool for an explosion. In flames subtab, we're not gonna do anything. In the smoke, we now want to emit some smoke in here. We want to emit smoke, and we want to create dense smoke as well. We're going to source it from the heat. We're going to put smoke amount a little bit higher than usual. 1 is default, so we're going to put it to 2. And that's it. And gas, temperature, and fuel, we're not going to do anything. So let's take a look at what this looks like. Let's switch these things off for now. And let's just see, let's have dissipation on still. But let's see where we are right now, what all of these things has led up to, and see what we have. So I'm just gonna simulate. As remember, it's gonna start on frame 10, which is now. All right, that's cool. That's, I mean, it's a half decent explosion, I'd say. There's a lot of work that can be done. We can add more elements. We can add tendrils or trails and stuff like this, but it's quite decent, I'd say. Now you obviously can go in back in here and define more things in the shape tab. We're gonna turn on the turbulence and confinement and some disturbance. I haven't done much to the disturbance and turbulence, to be honest. Disturbance, I lowered the block size a little bit to 0.5. In the turbulence, what did I do? Pulse lengths, I made it a little really high, really slow pulse length. I made the small size a little bit bigger. I turned on some confinement, which is gonna make a really cool pumping effect. Yeah, I think that's all for the shape tab I did. And let's have a look at what that looks like with all of those shape things turned on. Let's see. That's cool. Alright, sweet. Yeah. So this is what it looks like from upside. Boom. And you can obviously play with all of these. You can play with the velocity multiplier here. You can switch off the gas damp. You have so many options. You can play with these. What happens if you lower the burn rate? What happens if you higher the gas release? I don't know. You just have to play around, kind of dial in your things and get your explosion looking to where it looks realistic and also really cool and like cinematic kind of. But this is how you set up the explosion. Yeah, I encourage you guys to take a look at this file, take a look at this setup, go over to each node, play around with values, see what's connected and what's using what field, and have a play with this basically, because that's how you're gonna learn how to do this. But yeah, hope you guys enjoyed this. Thank you guys for watching, and I'll see you next tutorial. Bye.